Good to see so many of you for this ancient history lesson called Java 8. I'm not Josh Long, he's further there, so if you're in the wrong building, I can understand. I mean, I'm giving a history lesson today. And yesterday I was talking to one of the other speakers, and he asked me why Java 8. It was like 2016 called. They want their presentation back. I'm like, okay, yeah, I can understand, but you know what the problem is? I think Java 8 is the new 6. I mean, how many of you, just want to have a show of hands, how many of you are on Java 9 in production? Nobody. Okay, look on the bright side. How many of you are on Java 10 in production? How many of you are on Java 8 in production? How many of you are on Java 7 in production, or trying to migrate to Java 8, or in a transition? Still a few. And that's why I think Java 8 is still of importance, because I can tell you all the fancy stuff of the new Java versions, like, wow, we've got new vars and kind pattern matching, but we're not working with that. I mean, Java 8 is what we're working on from day-to-day basis, right? So let's look at Java 8, because Java 8 brought us some new things. And you see, if you see the Java perspective from a few years ago, there were some releases that some of these releases were important, some of these releases were less important. So if you look at the schedule from the last few years, and you see Java 9 and Java 10 already in it, Java 5 was very important to us, right? It had generics and enhanced for loops and auto and unboxing, which are things inside the language constructions that practically change the way we are coding right now, and we still use that. Java 6, does anybody know what came in Java 6 as new features for us as developers? Shout it if you think of something. Huh? The most important parts were JDBC 4.0 and JaxWS 2.0. Cool. Did that change the way we code? I don't think so. But Java 6 was there for a long time, until Java 7 came after so many years. We know the history lesson about that. And you know what my favorite feature of Java 7 was? This one. Underscores in literal numbers. It helped me a lot. Okay, then Java 8 came. They promised us all sorts of new things. And we're going to look into that. Java 9 and Java 10 are already out. Java 10 implemented JEP 3.22, which is the time-based released pattern. And I think many enterprise organizations are afraid to migrate to the modular system of Java 9 and further until, I hope, Java 11 is out. I think the time-based release cycle is something good, but in practice, I don't think many big companies we are working for are able to do that in that pace. So I hope from Java 11 that somebody is thinking, okay, now we have long-time support, we actually migrate to it. But until that, we're stuck to Java 8, or even try to migrate to Java 8. Java 8 came out in 2014, March 2014. It gave us, it's approximately 3 years after Java 7, which is quite quick. And it had some features that would change the way we are coding, we would code. It demanded from us that we could think more in a functional way. It gave us things like higher order functions and that kind of stuff. It gave us some life-changing code constructions. Well, we're here. Java 8 is already deprecated, perhaps, if I can say it that way. Let's look at the good, the bad, and the ugly things for it. My name is Brian. I'm a software consultant, software engineer for a small company called Blue for IT in the Netherlands. And we work consultancy-based for the larger companies in the Netherlands. Currently, I work for a large bank, Rabobank. Don't know if you heard of it, but I do projects over there. I did projects for the government. We code. That's what we do. And from that perspective, and from transitioning from Java 6 to 7 to 8, I will give you this talk. But first, I have, I have this disclaimer. It's not an Oracle disclaimer, but A best practice is a commercial professional procedure that is accepted or prescribed as being correct or most effective. At the end, it's just an opinion. I will say some things that can be considered a best practice. It's well documented, it's well researched, but in your case, perhaps there is an edge case that you will say, well, I should do that. And you're completely entitled to do it. I just give you my opinion. That's it. These were the main selling points of Java 8. I mean, parallelization was something they were marketing about. Less boilerplate code with Lambda, so fewer lines of code. They would give us new solutions to problems we had for ages, optionals, for instance. And with less lines of code, you should have you could minimize the amount of errors. Because if you take the rules of software engineering, if you write less, you can make less mistakes, right? Let's dive into the first one, it's lambdas. But first we have to know what a lambda is. Because many of you are Java programmers, perhaps even other imperative languages, and many of the people who work with imperative languages are not quite used to working with the functional paradigm, because it's quite a shift. So what is a lambda? A lambda can actually be pronounced like this. It's an anonymous inner function, or we can treat it like that. It's actually a function without boilerplate code. We simply have only the part of the function that's important without all the ceremony around it. But then we have to ask ourselves, what is a function? Before Java 8, we didn't know any functions. There were no functions, because we work in an object-oriented world, right? So we have methods. And methods are actually subroutines of a class. A method has to live inside a class. So what is a function in that case? Well, if we look at the Java perspective, a function is simply something that satisfies the functional interface, which is an interface with only one method and has the annotation of functional interface above it. Sounds pretty straightforward, right? So how do you write a lambda? Well, you see it on the bottom line. Basically, you write in the input parameters an arrow, and then we have a function body. So no public static whatever on it, just the easy way to go over there. Some new functional interfaces in Java 8 were these. These were the main functional interfaces. Of course, there were many more, like buy functions and that kind of stuff, but predicates, functions, consumers, and suppliers. Well, a predicate gives you something is true or false. A function takes something, gives you something back. A supplier generates something out of thin air. And a consumer takes something and does something with it. Just a few examples, quite easy. Well, if you look at this, you see the anonymous inner function in red, and then you see I declared it to a variable. Actually, that is bad practice. I mean, we should consider it anonymous inner functions. That means that we can take that function and give it as a parameter to another function. Why in God's name should I assign it to a variable then? Of course, I said we have more like these. Buy functions, for instance, they take two parameters and it does something with it. But we actually knew these functional interfaces already, because in Java 7 we had these: comparables, callables, and runnables, right? These are actually interfaces with only one method. So if you were working in Java 7, you could do this. We have a list of beers. Some people tend to drink coffee. I like beers. And if I want to sort my list, I had to do all kinds of nasty stuff with an override, and I had to implement a compare method, whatever. But the only interesting part is this. The rest is boilerplate. So doing this in Java 8, the comparator is also a functional interface. We can now do it like that. We can call the collection.sort, or because we can have default methods on interfaces, we can actually call sort directly on the list. And we only need to give the important part of the function to the sort method. So now we can give behavior to a function, which is quite cool. And you can do that yourself for your own functions. I mean, you can now write some layer of abstraction in that case. If you have something like this, say we have two almost identical functions with a lot of code in it. I mean, there's some super interesting code above the red line, there's some super interesting code below the red line, and only the red line is different. What you see in practice is that people tend to copy the one and paste it over there and only change that one line. But we all know that copy and pasting causes us, well, some problems. Can be changed. It can be, perhaps it's not the way we want it to be. I mean, it's error prone, right? But we can do it now with a higher order function, and we can make an abstraction like that. We make our combined function in our do-foo method over here, and by giving a logger up and a logger low, and calling that do-foo method with a particular function, we can now create our own layer of abstraction, which makes it quite readable and quite maintainable, I guess. So no copy and pasting anymore. We now created our first higher order function, which is quite cool. So, lambdas. We have two ways to write lambdas. We have single line lambdas, and we have block lambdas. Of course, we have a third, but it's not a lambda, it's a method reference. A method reference is actually if you have an input in the lambda and you provide it without doing anything to a method, you can write it in a different way, like this. I can call a string and call the system at println, or I can do a method reference. There is a debate about it. I mean, first of all, if I want to change it because I'm coding and, okay, I need to do something more, and I need to do something more with that string, and now I have to transfer it back to a lambda because I do want to do something with my input. Some say that method references are cleaner, are better. Some say that it's not. I mean, if you talk to Stephen Colbert, he would say, I think the upper line with the arrow is more readable. I think it's for you to decide. I personally don't care if somebody writes a lambda on with the upper line or says, I want to do it in a method reference. I think if you're trying to learn to write lambdas, it's probably easier to do the first one because input, arrow, output is very straightforward and very readable in my opinion. But I can imagine that some people say the lower part. I will not take any of these parts. Just figure it out for yourself. But some say the lower part is better, some say the upper part is better. It's a choice. So, talking about block lambdas and single line lambdas, I hope you're all awake because I've got something for you. I've got a little puzzle for you. This one is a list with 3 beers, and then I want to sort it with a lambda. Take a look at it. I want to know if line A compiles and line 1 compiles and line 2 doesn't, line 2 compiles and line 1 doesn't. Both lines will compile. Or yeah, it's late, I know, and we all like that beer, so D is always the correct answer, of course. Who says D? Good for you. See you at the party, right? Awesome. Who thinks that A is the correct answer? A few, all right. Who thinks B is the correct answer? So everybody thinks C is the correct answer? Who thinks C is the correct answer? And on second thought, who's thirsty who thinks D is the correct answer? I'll give you the correct answer. The correct answer is A. And now, stunning thing is, why? Because of this. The first one, and we'll take the annotation away. The first one is a single line lambda. And a single line lambda is, in my opinion, how a lambda should be written. If you use a single line lambda, you can have an input and you can have an output. If you use the curly brackets, and I sneaky did it over here, you're actually initializing a block lambda. or a multi-line Lambda. And now I'm paraphrasing Venkat. If you're using a block Lambda, which you shouldn't, they punish you by you to have explicitly returning the value you have to. So the first one, I don't need to return. The second one, I need to have the keyword return on it because I'm writing a block Lambda. Normally, you would write a block Lambda like this. I'm doing two things in my Lambda. I have an input doing a side effect, and then I'm giving it an output. And you see the return statement over here, right? That's because I'm using the curly braces. And actually, what I'm doing is I'm implementing a function body. If you're doing more than one line in a Lambda, I would say you're doing too much. If you're writing 2 lines, you're doing 1 line too much. If you really need to do more than 1 line in a function, just create a method. By just creating a method, and please give it a better name than my method, of course. Silly example, I know, but naming is the hardest thing we have, right? How do I name my function? But if I give it a proper name and it describes what I have to do and what I'm doing with it, I can call my Lambda in 1 line, or I can do a method reference, whatever you want. And the problem is, normally you should give a Lambda as a parameter to a function. Can you imagine that you write a Lambda like this? And people tend to do that. Yes, let's do if, else, try, catch, whatever, and then give it inline to a higher order function. Will that be more readable or less readable than the old-fashioned kind of way of coding in Java 7 and before? So I would say stick to single-line Lambdas, and if you have to do more than that, convert it to a method and call that method. What more about Lambdas? Within Java 8, we have type inferencing, automatic type inferencing. So Lambdas are actually designed to have to do the same with less coding, right? So why would I give the type of my arguments here if it's not necessary? I mean, you write a Lambda inside a context, say for a map function or a filter function or whatever higher order function. Most of the times, the compiler already knows what the type of the input parameters will be. Keep it that way. Don't over-verbose your function with writing these types in it, because by doing so, you're making it verbose again, and that's what we want to try to get rid of, right? The same holds for brackets, for parentheses. If you have only one input, you should not write parentheses. If you give it with parentheses and more parentheses and more parentheses as a parameter to another function, it will be less readable. And the subject of doing this kind of functional style of programming, or declarative style of programming, which I have to say, is to write more beautiful or more readable code. So let's go to the elephant in the room. What about exceptions? So question for you guys. How can I throw a checked exception from inside a Java 8 stream or Lambda? Who has the correct answer for me? Well, there is the correct answer, because the simple answer is you can't, at least not directly. It's not possible if I have a function like this, and it throws, for my beers, it throws an isEmpty exception, which I have to check, of course, because I hate it when my beer is empty. So it's a checked exception. And now I want to write a Lambda which calls the thatDoSomething function, and you cannot do it because the isEmpty exception in my case is a checked exception. Okay. How people tend to solve this is writing again a ugly-ass block Lambda, doing a try-catch in it, and yes, it compiles, and yes, it works perfectly. But is this readable? Who thinks this is readable? Is readable, usable code? If you want to punish your coworkers, yeah, perhaps you can do it like this, but I don't think it's the correct way. What you can do, if you really need to do something with that checked exception, is wrap it into a method, perhaps, if you really need to do something with it. And then call that method again. So at least your Lambda is readable and safe and not that verbose, and you leave the verbosity to your wrapper. Very possible if you really need to do something, if the exception is thrown. But let's be honest. How many times do you have an exception, wrap it into a runtime, and throw it up again? I do, because 9 out of 10 times in my code, when there is a checked exception, it's actually the end of the world. Because on forEnd, I will check if my file is available, if that stream is available, if I can read something or write something or not. And if it's not, then there is something wrong with my function, and that's only in runtime. So what you can do, for instance, is to write a utility with your own functional interface. In this case, a functional interface that actually accepts a throwable. And then you can write a generic wrapper, and yes, I did it in an ugly block Lambda, but in that way it fits on the slide. And I will tuck it into my utility file and never touch it again, so nobody sees it, right? But in that case, I can still use my Lambda by simply wrapping it into my wrapper. If you're asking real functional guys who did these nasty languages like Haskell or whatever, they would say you have to use monad. That's scary. I would say you probably can look into something like the either type. I think Scala has that kind of type, but there are these kind of types in libraries like Favor and Joule and that kind of stuff. It is a way to go if you think that an exceptional situation is something that can happen and I want to continue my stream. But it's not in core Java 8, so I will not get into it now. What I will get into is optional. Because optional is the new kid in town, right? Optional is actually a monad. It's the Java implementation of the maybe monad. Again, very scary. Nope. It just encapsulates the thing that some value can be of a certain state or can have a certain behavior. In this case, a value can be empty. And when optional, we try to catch that and grab that and package that, actually. It's a new thing in Java 8, and it's actually just a wrapper. Just consider it a wrapper. And what you do with it is you give it back to your user to make sure that he actually checks it. So we're trying to prevent a null reference over here. Of course, with these kinds of things, there are different opinions about it. Some say it's awesome, some say it's the most utterly ugly thing in the world. I think it's a good start. Because normally you would do something like this. You have a function that gives you a string. Yeah, it can return null or it can return a string. And now we use optional, and optional should be used as a return type, in my opinion. And we warn our user that something can be absent. So if it's there, we give an optional of our string, and if it's not there, we give an optional of empty. You may think now that optional has two variants, like it's filled or it's empty. And there where you go wrong. Because an optional can be nil. We are living in an object-oriented world, right? So, and there are still some people that first initiate all the variables they're going to use and probably set it to null. And if you do that with an optional, we still end up with the same crap that we had before. Because now we have to check if it's null, and then we can open the optional. So please avoid this. If we just make the promise to each other right now to never, ever, 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 ever set an optional to null, we have no problem at all. So, how do you use an optional? Avoid the first thing, please. If an optional of nullable is, this is kind of way like, okay, I have a new toy, I want to use it, so I wrap it into an optional, and I ask the optional if it's present. Why is this, in God's name, is this better than just the null check? I don't think it is. You should be doing the second line. If present, do something. Use optional in a more functional way. Say I have an optional at my findBeer function, and I want to have that beer dedicated to my variable b. Well, I just find beer or else do something. Or if it's not there, or else throw something. And I want to show you something, because the or else is a nasty one. Yes. Now we're there. And so, can you all read this? Or should I? Is it readable in the back or not? No. That's because of my resolution. I will do it differently. I will go out of my presentation mode, and now I will just... I thought I could blow it up. I can blow it up. Awesome. You can write it. You can read it like this in the back. Perfect. So in line 10, I have an optional, and it's the optional of and this optional is filled in this case. Say that my string wants to be like this. I have this optional, and I say, okay, right? I set my maybe string. Say I want to, first of all, I want to map something, and I have the function over here. Well, if it's if there's something in it, I have a string, and I will call, and I say run if empty, and I will supply it as. Of course, I can do it as a function as a reference, but I don't want to. Or else, well, run if empty, and I will output it in line 14. You probably think that the value of str will be foo, right? Let's run it. Oh, let's go something wrong. Yes, I see it. What you see at the end is that actually foo is the value of my str. Only what you see, what the other things that you see is that both functions have a side effect. And despite the fact that my optional is filled, the string, the print line in run if empty is also in my output. So that means despite the fact that my optional is filled, my or else is evaluated anyway. The first time I saw it was like, huh? Normally you should do something like short-circuiting, or you would expect to have something, to have a different result, right? This is a bit counterintuitive. If we wanted to do it that way, we should do or else get and make a supplier out of this, and then run it. And then you will see that the or else get or the or else is not called at all. It's not evaluated because we don't need it. My optional is filled. So there is a tiny difference between or else and or else get. The or else is actually to provide you a default value. Yes, you can call a method in it, but you have to make sure that what you do inside the or else is free of side effects. It's idempotent. It gives you a value. Because, say for instance that I have a function that looks if a user is in my database, or else create it. Well, in the first example I showed you, you do that, then you have a duplicate record. And if your database engineer wasn't that good, you end up with a crappy database. The or else get is to do a different kind of flow. If you want to do, you want to call a different flow because an optional does not exist, please call the or else get. So there's a subtle difference, but it turns out to be massive if you do this, if you find this out in production, right? Let's continue with the slides. Yes. So, optional can have 3 options. Be aware of that. It can be null. Never assign null to it. And actually, you should choose how to use optional. Do I want to use it everywhere? Do I want to use it only where it's publicly available, or I don't want to use it at all? It's up to you and up to your team. Personally, I think it's a good way to use optionals at in public functions. You warn your user, you warn the user of your library that something can be empty, something can be absent. Don't use it, in my opinion, as a parameter of a simple POJO or something. So optional is designed as a return type. Let's go into streams. Streams were actually designed because more or less loops are the same every time. We do a lot of repetitive code in that, and perhaps we can do it in a more functional way. But what is a stream? First of all, what is it not? A stream is not a data structure. And I repeat that it's not a data structure because it's very important. People tend to use streams as data structures. It's a derivation of a data structure. A stream is something that is derived from, say, a collection or something. It's something intermediate. It's not and that feels a little fluffy, right? It's not hard. It's something intermediate. It's an intermediate result. And it's lazy. And that's cool. Laziness is always good. Never do a thing you don't have to do until you have to. Really, really have to. It's just like having kids. Jim, please take out the garbage. Yes, Dad. Jim, did you take out the garbage? Yes, I will in a minute. Jim, if you do not take out the garbage, I will. Whatever. And then it will kick off, right? That's the same with streams. In streams, you can transform data. You cannot mutate data. Well, with some silly tricks you can, but you shouldn't. Don't mutate data in a stream. Streams are not designed for that. And what you can do with a stream is create a pipeline of intermediate functions and then kick it off with a terminal functions. And then we come to the next part. Because we have 2 kinds of functions on streams. Intermediate functions, which give you back a stream, and a stream is lazy, and a stream doesn't do anything. A terminal function sets it off. It ignites it. It kicks it. Like, okay, now you have to do something. So, and if I build up a stream with only intermediate functions, it's just code. It doesn't do anything. It's dead. If I end it, like you see over here, with a collect, which is a terminal function, the collect initializes the stream and kicks it off and actually makes sure that it does something. So then you see this kind of code, and the people were very anxious to use stream, and everybody was like, okay, cool, we can refactor it to this. Well, it's quite okay. But first you have to decide if the first one or the second one is more readable. And I think it's an opinion. I think the second one is more readable. The first one with brackets and an inner if I don't like. But you have to make sure that if it's just a for loop which does one line, is it actually worth to transfer it to a stream? Does it make your code readable? Because that's the thing you want to, right? What you do with a stream is using the higher order functions like filter and map, and what we now do is describe what we do instead of how we do it. But you shouldn't apply it. You shouldn't have to apply it to all loops. If it's readable for you, it's okay. Then we have the forEach method. forEach is a terminal function which can hold a function that does a side effect, actually. So what forEach does is simply nothing more than syntactic sugar for iterating over the complete list. So laziness is thrown out of the window. We do this to every item in the list. So if you want to mutate something, you could only do this in the forEach method. But should you? I mean, I saw things people using forEach in a very different way, like this. We have our beers, and we have a second data source that gets me my ratings for that particular beer, or my reviews for that particular beer. And people were like, okay, for each beer I will do the ratings, and then for each beer I will do the reviews. It is a declarative way of programming, because you describe what you do instead of how you do it. But what you do now is you loop over the list once, you loop over the complete list twice. Not very efficient. What you could do, and if you want to use streams and you want to use the declarative way of programming in that way, make sure that your beer is immutable, and that you actually create a new beer with these ratings, and you create a new beer with these reviews, and now you can use the stream.map, and a collector, and you have a new list of immutable versions of that beer with ratings and with reviews. But that's a whole different style of thinking. And you should test if that is applicable to you, because if you have a very time or resource-sensitive program, you are creating new objects. Mutable objects are very good in the way of reasoning. I can reason about it. I do not have to keep a mental map in my head what the state of an object is. But if your resources are important, you're working on smaller machines, you perhaps don't want to do this. Another puzzler to keep you awake. Besides my work as an engineer, I also am a soldier, and I had to make I had to plan a mission a few days ago, and I had these teams at my disposal: Alpha, Bravo, Charlie, and Delta, which are my normal teams. But I had a call from team leader Bravo. And he said, my team is not complete, I don't have enough men. I said, okay, I have a spare team Echo in the race. And I put Echo in. But I already declared a stream. So now, teams in my mission, I do a forEach on it, and on each team I just simply print it out. Can somebody tell me what will happen? What will be the output? Alpha, Bravo, Charlie, and Delta, as I suggested in the first place. Alpha, Bravo, Charlie, Delta, concurrent modification exception. Alpha, Charlie, Delta, Echo, as I actually want it to be. Or do I get a concurrent modification exception? Who thinks A? Some of you think A. Who thinks B? Nobody thinks B. Okay. Who thinks C? And who thinks D? Well, the people with C did their homework. Because the problem is, I was talking about laziness, right? I just put the stream at a variable, nothing more. The forEach method is the one that kicks the stream off, that makes it work for me. So before that, a stream was not a data structure. A stream was something intermediate, right? And lazy. So until the forEach method is called, I can do anything with that stream. But the forEach method actually kicks it off and makes sure that the remove was already done and the add was already done, that C is the correct answer. You should only use a stream once, because it's not a data structure. Because if you use it twice, you will get an exception, simply. You should not even store a stream into a variable, in my opinion. You should use a stream right away. So please make sure to not reuse a stream, and I would say don't ever give a stream back from your function. Because if you give a stream back to your function, from your function, what the user of your function has to assume that the stream is already consumed. So you can't do anything with it anymore. Or you have to take the leap of faith that it isn't consumed, and you find it out in production, and then you have a small problem, or a big problem. So please do not use a stream twice, and please do not give a stream back from your function. You should consume a stream, and this is a nasty one, because if you read it, you will say, okay, eventually if if I have enough beers and one of the beers has a alcohol percentage that is bigger than 7, it will give you a runtime exception. But peek is a nasty intermediate operation on streams. Peek will give the stream back as it is, but applies a side effect, can apply a side effect. Peek was actually only designed for debug reasons. For instance, to print out the values of the stream that come by. So in this case, the first, the second, and the third one are intermediate functions, so it doesn't do anything until you give it a collect or a split or whatever. Anytime you have to give it a terminal function at the end. It's pretty good to use multiple filters and multiple maps in your stream. People tend to make, okay, I can do a map, I can do a filter, and make their function so big that it's not readable anymore. And it's pretty obvious what we do over here. In my opinion, this is like building an IKEA closet. Step 1, I filter. Step 2, I filter again. Step 3, I map. The only thing we want to do over here is make something more readable. So make your function small. Please make sure that filters and maps can be used multiple times. It doesn't matter because it's done lazily, so whatever. And make your code readable. Then we come to infinite streams. Because they are lazy, we can use infinite streams. This will run forever and gives you every number, every integer in the book until it runs out. Normally, you would limit it or something, and you will say, okay, now I have 10 objects from my iterator, and I printed it for each. Well, let me give you this one. This one runs forever, and I will show it to you. I have 10 minutes left, and I will show it to you. No, I will not run it for 10 minutes. First of all, this. You will see it over here, right? Let me run this one. And what you see is that 0 and 1 are in my console, but it doesn't terminate. If I actually look over here, you will see that it's running and running and running and running. And why? Because we made two subtle mistakes, actually, in this case. First of all, we are using an infinite stream, and we didn't take care of proper testing. What does this stream do? It's quite silly. It gives me a stream back of 0 and 1 and 0 and 1 and 0 and 1. So it gives me this, 0, 1, 0, 1, 0, 1, forever. Then I say distinct, which gives me 0, 1, which says limit 10. Okay, the first one I have is 0. The second one I have is 1. The third one I have is, I'm waiting. So actually what we did, the order of our intermediate functions, I did it the wrong way. Because if I do the limit, let me just get this gone. If I do this limit over here, and I'm going to run it again, it perfectly has, because I have 10 items in my stream, I will distinct it to 2, and it gives me two items back. So first of all, the order of operations is very important, and you have to take care of the fact that an infinite stream actually runs forever, and it will keep your thread busy forever if you're not watching it properly. Can you imagine if I do this? What will happen? Yes, saving caches, whatever. Oh, it runs twice now. But you see what happens? It doesn't only occupy one thread, it occupies all my threads. And then Yeah, it's getting hot here. So let me kill this one. Yes. Oh, I still have some running. All right. So we should be careful about it. Should be careful with working with infinite streams and make sure that they actually terminate. And therefore, the order of your operations are, in this case, are very, very important. Because parallel even makes it worse. You have to watch out with parallel. Because parallel sounds good. Sounds like a magic wand. Sounds like something, okay, if you use parallel in it, I will occupy all my threads and it will run faster. But if you just use parallel and don't do anything special with it, it will use the fork join thread pool. And the fork join thread pool is not one infinite bucket of threads. If you use parallel in one occasion, it perhaps makes your stream go faster, or your operations. But if you use it everywhere, you will find out that it will actually makes your program a bit slower, and even more slower. So you should only, in my opinion, use parallel when needed. Most of the times, parallel isn't really needed. Parallel can actually slow you down in some ways. So, streams. First of all, you don't have to replace every loop with a stream. People tend to think like, or we as developers tend to think like, we have a new toy, let's do everything with that new toy. But you shouldn't. You should use it carefully. You should use it wherever it makes your code more readable, because that's the ultimate effect. Be careful with infinite streams. I just showed you that my laptop was getting hotter and blowing air. We should only use a stream once, because if I use a stream twice, I will get an exception. It's not a data structure. Be careful with parallel. Again, a stream is not a data structure. And streams don't do anything until they have to. So to sum this all up, Java is an object-oriented language. And Java will always be an object-oriented language. There's nothing wrong with that. They just added some features that give you a functional kind of way of programming with it. And you can work in a functional kind of way of programming with objects. There's no problem with it. It's not like it's one or the other. You can intersect with it. These things like having higher order functions are things like that functional programming languages had first. But we can simply apply this one to object-oriented. It's not something you have to have functional languages for. Java is not a functional language. It will never be that way. So there are some nice new code constructions that you can use. Use them with care. I mean, if you apply it everywhere, it perhaps will not make your code readable. So I will end with the slogan, we have a cowboy over here, Mr. Clint Eastwood, don't be a cowboy yourself. If you want to know more about the puzzlers, I actually stole a few puzzles. I didn't make that myself. I just added them to make it work in my session. But go to the session over here from Baruch and Victor. They had a whole session about Java 8 puzzlers, which is very, very fun to watch. It was for the VJEC from last year, I guess. And if you want to know more about optionals, it was DevOps Belgium talk in 2016 from Stuart Marks, which has the view on how optionals were created and why optionals were created and how they were intended to be used. My name is Brian. I work for a company called Blue for IT, and I have a few minutes left for questions. So if somebody has a question, please fire. If you do not have a question now, this is my Twitter handle. I will be at the party, so we have a conversation starter. I will be around. You can ask me. So, are there any questions right now? Yeah?
Any particular reason why you didn't include a completable future in your presentation?
Yeah, the question was, why didn't I include completable future in my presentation? Because I only have 2 minutes left now. That's the answer. I had to scratch I had completable futures in this presentation earlier, but it was just due to time I had to work the fact that what are the problems that come most with Java 8. And yeah, completable futures are still an interesting point, but I had to make choices. That's the only thing I can say. I do not have any other reasons for that. If there aren't any more questions, I would like to thank you. I would hope that you have a very lovely day, and perhaps I see you here at the conference or perhaps tonight at the party. Thank you so much.